this would be it's 2 and it's 1. Good. Okay. 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 Now, look over here. It's Ca plus 2 and it's a 4 minus 2 minus. So, technically, if we look at the point number 2, it says simplify the charges. Can the charges be simplified? Yeah. So the formula becomes CaSO4. Okay? Okay. What about calcium oxide? It will be CaO. Or it's Ca plus 2 and O minus 2. Really? It would cut it, right? The charges are simplified already, so it becomes CaO. Okay, magnesium nitrate. Uh, Correct. And a 3 minus 1. Nitrate is here. And a 3 minus 1. Okay. Yes. And 2. Correct. Good. So you've learned it really fast. Okay. So while writing a chemical equation, you must know the correct formula. And the second thing is you must know their physical states. Okay. How to write a physical state? Mostly, most elements are soluble in water. Most salts are soluble in water. Only some are not. Which are not soluble. Let's talk about those. Have you done the solubility table already? No, I haven't. I don't think so. You have done it. No, right? Okay. Let's say the carbonates. Okay, all potassium are soluble. It would be difficult. No, carbonates are not soluble. Um, some sulfates like calcium and barium sulfate are not soluble. Calcium and barium are not soluble. Now the soluble one. If it has potassium, it is soluble. If it has sodium, it would be soluble. If it has ammonium, it would be soluble. Okay, these salts are 100% soluble. Even is potassium carbonate. Carbonate is present, but if potassium is there, it's going to dissolve it. Okay, the soluble or you can say a dominant. If it's ammonium carbonate, it would be soluble. Okay, if it's ammonium sulfate, it would be soluble. If it's sodium sulfate, it would be soluble because potassium, sodium, ammonium nitrate, they all are soluble. Okay. Okay. So when we write a symbol for a chemical equation, because we have to write the state symbol. What do we write for gases? For gases, we write G. Like if we are writing hydrogen, we have to write G in the bracket. If we're writing oxygen, we have to write O in the bracket. Oh, sorry, G in the bracket. If you're writing CO2, then we have to write G in the bracket. Okay? Okay. The soluble ones. For the soluble ones, we write AQ, like the aqueous solution. They're soluble in water. The aqueous solution. Okay? The insoluble ones, are written as S. S means solid. They are not soluble. They are solids. Metals are also written as S. Okay. What else? L. L is left. So water only. Water only. If not present in the form of steam. For steam, we write G because it's a gas. But for a regular water, it would be in liquid state. You must know these five things. Okay. Okay, what about the non-metals? What do you write with fluorine, chlorine, bromine, and iodine? Let's now evaluate your memory, whether you remember these or not. Fluorine and chlorine are they are okay. What's their physical state? We did this last week. Okay, so the fluorine and chlorine are gases. They are like greenish, pale green gas. We read their colors as well. Okay, bromine is a brown liquid, right? And the iodine, that is a purple solid, right? So we just need to, like, it comes with practice. There's no need to cram it, it comes with practice. Okay, let's write the correct chemical formulas now because we skipped this part where we have to write the equation. Okay, what would be equation for this one? Potassium hydrochloric acid, potassium chloride, and hydrogen gas. How do we put this into equation? Potassium is K. It's a metal, so we have to write S. Okay. What is the formula for hydrochloric acid? HCl. And what symbol are we going to write for this? Okay, acids are mostly aqueous. Acids are mostly aqueous. Okay, let me write here for you. Acids or alkalis are aqueous because it's their definition that they produce hydrogen gas or hydrogen ion or hydroxide ion in aqueous solution. So we write aqueous with them. It's in their definition as well. Okay. What would be potassium chloride? The formula would be potassium chloride. Hmm. Hmm. And what's their symbol? AQ. Very good. And for hydrogen gas, we write H2 and state symbol is G. Good. Okay. Calcium is Ca. It's a solid. It's a metal. It's a solid. Sulfuric acid is yes. Is correct. H₂SO₄. We did this here. Calcium sulfate. CaSO₄. Okay. We have written here the solubility one. Calcium sulfate is mostly not soluble. Okay. Okay. Now I'm giving you an equation which you need to write and complete both. Okay. This is your, let's say, assignment for now. because we have to do papers as well. Okay, here we have, let's say, zinc with sulfuric acid, iron with sulfuric acid, and potassium with nitric acid. Okay, nitric acid is HNO3. Okay, now you have to complete this and send me. Just tell me, I will write. I'm giving you like 4 or 5 minutes. Think, 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 and then write. Okay, take your time. How to write zinc and sulfuric acid? Zinc would be ZnS. Okay, sulfuric acid is H₂SO4 AQ aqueous. Okay, good. Okay, good. AQ, good, good, excellent. Okay, let's move to iron with sulfuric acid. Good, 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 good. Okay, potassium with nitric acid. Okay, solid. HNO3 AQ. Okay, good. AQ. Good. Excellent. So you know now how to write an equation and how to write the chemical reactions for metals with water and acids. This is what we have done today. Okay, let's discuss few questions. So let's discuss this part E, that a table is given and five elements are given and their reactivity is somehow given. Like beryllium, there is no reaction with cold water, but it burns strongly when heated with air. Okay, so magnesium, it reacts slowly with water, but it burns when heated. Calcium also reacts slowly with water and is also reacts slowly with air without heating. You don't required heat for this one. Okay, strontium react quickly with both water and air. Now you need to suggest what what can be the reactivity for the the barium. Yeah, barium is given. Okay, good. So as we have seen that the reaction is becoming uh, quicker as we move down the group. So both react quickly. Good. Okay. Suggest how barium reacts with a coal. Okay, this we have done. Okay, use your answer to E1 to suggest how barium should be stored. Like if it's a very reactive metal, how should we store it? This we haven't done. So how do we store the group 1 elements and group 2 elements, because there is lots of water vapors in the air. So if we kept them in the air, they are going to react really fast, right? So we need to keep them in some oil or in some paraffin material. Store them in oil. You might see in your labs that, because it's a lab thing, the sodium, potassium, we need it like for certain test. So they are stored in a jar in which has paraffin. Paraffin is also a type of oil or paraffin. Okay. Suggest the connection between the atomic number and the reactivity. Like if you look at these atomic numbers, as the atomic number increases, the reactivity is also increases. So what would we write here? What is the relationship between reactivity and atomic number? Okay, and how do we write the answer? Okay, good, good. Okay, next part. Again, group 7 is given, and you have to tell the reactivity for this one. Let's predict the reactivity for the halogens. Astatine has the atomic number of 85 and is the fifth element in the group 7. Is it possible to make prediction about the astatine? How many electrons does the astatine have in the outer shell? 7, because it belongs to 7 group. Okay. And what is your prediction? What is the physical state and color? This question we have discussed already, this physical state and color. Good. Okay, let's predict the formula for astatine and hydrogen. So let's say hydrogen and astatine is AT. What can be their formula? What is the charge on hydrogen and what is the charge on astatine? +1. Astatine is, okay. So what will be the formula? HAT. Okay, and what would be the name of this? Like hydrogen chloride, hydrogen fluoride. So what would be formula? Astatide. Okay, when you compare the reactivity of iodine and astatine, what is your prediction? So in group 7, what about the reactivity? Is it increases down the group or decreases down the group? So astatine would be good. And why? Good. Okay. So first of all, let's write, if we, as the atomic number increases, the reactivity would decrease. Is it so? Then we can write, due it happens due to increased shielding effect. Okay, shielding effect. Done. Okay, this is all for today. I may assign you like some quiz. I've given you the link, right? You just need, okay, okay, oh, okay. Uh, Let me try it myself, then I'll let you know in the chat, okay? Okay, do you have any question? Because we haven't done much today, we just learned about the reactivity and the reactivity series for metals. And we did the reaction of metals with water and acids. Because we have to work on equations and formula, so this topic took time. Okay? I hope the next topics would be really quick because we are already done with formula and the equation.